Hello, my name is Ryan Ismerlian and I'm the Conveying Product Engineer here at Novatec. Today, I'm here to talk to you about vacuum loaders. Vacuum loaders are self-contained vacuum systems that allow you to pull material from point A to point B. Point A is your source, where that may be a Gaylord box, a barrel full of plastic material, or even a bulk bag. And B will be your destination. Now that could be a surge bin, could be another Gaylord box, could be a dryer, or another storage vessel. Self-contained loaders come as a pre-made package. You have your vacuum chamber, you have a built-on motor or some method to generate vacuum. You have flex line and a carbureted vacuum lance, or you can substitute that with a vacuum probe, depending on your pickup location. Now, vacuum loaders are primarily used for pelletized material or clean-cut regrind. There are alternatives that allow you to handle more rough regrind or granulates and powders, and we'll touch on those later on. The three loaders that we have behind us are our main offerings. We have our VL, which is our traditional workhorse. We have our GSL, which is right here behind me, as our gold standard loader. And then we have a mid-tier series that we call our XSL. Now, as you look at the three loaders behind me, the VL, the XSL, and the GSL, you'll see some notable differences, primarily between the VL and the two XSL and GSL. These two look very similar, but we will go through what makes them different. First, we'll start with the VL. What powers the VL is a brush motor. It is a tried and true technology that has been used in the industry for decades. The brush motor allows you to operate and replace brushes as needed, as they can be worn over time dependent on usage. And that would be a maintenance item that you'll have to maintain throughout the life of the unit. Where if you jump to the GSL, this comes with a brushless motor as standard. The brushless motor is, as it says, does not have brushes. So you don't have to worry about that maintenance for the unit. With the XSL, it has the same motor as the VL, but all the other features that we're going to go through that are similar or the same as the GSL. The motor makes a difference in maintenance, but it also makes a difference in performance. The brush motor has industry standard performance, where if you bump up to a brushless motor, like on the GSL, or optional for the VL, you'll have increased vacuum capability and increased throughput performance. Now with these motors, they can see a lot of abuse in an industrial application, so we have to find ways in order to protect them. And we do that by using a filter disc that is mounted between the motor and the body chamber where the material is collected. This filter is very fine, and it's a Dacron polyester. What this does is it collects any dust that may come off of the pellets and prevents the pellets from going up near the vacuum motor. Now, since it can collect this dust, it'll actually start saturating and you'll actually lose vacuum performance. So in order to extend the life of your filter, to reduce your maintenance and need to change these filters out, all motorized vacuum loaders come standard with what we call a filter blowback, or automatic pulse cleaning. And what this does is it utilizes compressed air from your facility, accumulates it in a chamber or accumulator, and allows that air to be pulsed open via a valve, which could be a two-way ball valve or a poppet valve, depending on the technology we're going to discuss. And that'll allow the air to flow through, clean the filter off, and push that dust back into the material so that it can exit with the pellets that are in the chamber. Now, the blowback technologies that I was going to mention include the one that we see on the VL and the one that's on both the XSL and the GSL. The VL uses a steel accumulator tank, and this allows us to collect that air and allow a flow of air to go through and clean these filters. It is highly effective. But once you get to the XSL and the GSL, we have what we call a microburst blowback. You'll see by looking at these units, you have the steel accumulator on the outside, Well, the microburst is built into the lid. This microburst is a rubberized reservoir that allows expansion within the lid to collect that air, but also add additional force via the elasticity of the hose. And what this will do is there's actually a built-in poppet that will, once the chamber is full and you take away that pressure from the solenoid by de-energizing it, it'll pulse a solid, sudden burst, which will impact the filter and push all that dust effectively and efficiently. Now we're going to look below the filter where the material is actually collected. If you look at these three loaders, you can see the body chambers are very similar, and they actually are. Each one of these bodies has an inlet check valve that helps allow the material to be deflected down into the body and collect near the cone. The bodies are the same, and also you can get wear packages that are similar that allow you to run engineering grade resins, so that can include glass or mineral filled. And we'll touch on wear packages a bit later. Once you go down, you'll actually see there's another difference. We have different cones and discharge flappers on these units. On the VL, you have a rigid cone that goes straight to the throat of your discharge, and it's actually a 2-inch discharge flapper. This allows you to evacuate the material from the chamber once the loading cycle is done. But once you start looking at the XSL and the GSL, we actually have a 3-inch discharge that's on the bottom here, but this one's a little different. So as you can see on the VL, there's actually a gasket, and that is based on how these two loaders operate differently. On the VL, we use blowback only during the dump cycle, where the XSL and the GSL, we used an initial pulse before the load cycle to clean off the flapper. So that allows us to utilize a metal-to-metal seal or a sure seal on the GSL and the XSL. So that eliminates another maintenance item that you would typically need to take care of on a VL. Now, on this GSL and XSL, it's a 3-inch discharge. And now that's increased in size so that it's more easily able to evacuate material from the chamber, especially regrinds that tend to bridge. There is another difference, which may be hard to tell from these stands, but the VL does not stand on its own. So when you handle it, you have to lay it on its side. But on a GSL and an XSL, we actually have shrouds built in so that, one, we can actually stand this up on its own whenever you take it out from its operational position. And two, allows us to shrink up the discharge a little bit more and have a low profile approach, which gives you more volume below the loader in your destination, whether that be a surge bin, hopper, or another Gaylord. So with those discharges, we mentioned the cones. So I already said the VL was a rigid cone. Well, the reason why I said that is if you look at the XSL and the GSL, it's a casted cone. Now there's a reason for that, because we actually have an additional feature that the VL does not have. With the VL, you can look, we have band clamps. In order to clean this receiver out, if you ever do a material change, you'll have to undo the band clamp and you can pull the individual body sections. That allows you to have easy access to the cone, the receiver body, and the filter and the lid. This also gives you a little bit of modularity to rotate the body where you need to when the discharge can be fixed. With the XSL and the GSL, it's a little different. We have what we call a tilt cleanout feature and a hinged lid. So everything stays together in one piece. Now, we do this so that you don't have to take anything down from a high position. It allows you to have easy access to the filter instead of having to hold the motor lid and pull the filter as well. So I'm going to demonstrate real quickly how this tilt cleanout feature works, along with access to the filter, since those both apply in this situation. So I'm going to take the GSL right here, and first I'm going to have access to the filter. So I'm going to undo 3 butterfly latches, and I'm going to lift the lid and lock it in place, and now you have access to the filter without having to hold it, and then you can put it back in. However, in this situation, I'm going to show you the rest of the tilt cleanout. So we'll pull the filter completely out, and then on the back side, we have a latch mechanism that locks this in place. We'll pull this pin, flip this lever, and I'm going to turn this back towards you, and we're going to push this forward. So now the receiver tilts towards the operator so we can reach in, clean this out, blow compressed air, and once you're done cleaning, you tilt it back. And then you lock it back into place. So I'll turn this back around, put it in the hole, turn it back this way. I'll grab the filter and put the lid, lift it out of the locking, and then latch everything back down. Now that we addressed the differences in the body, there are differences in the controls as well. So with a self-contained loader, you have individual controls per loader. And that makes it different than a central system where you have a single brain operating multiple of these chambers. Well, with these, we have two different control approaches. With the VL, we are utilizing a logo-based PLC. And that allows us to operate the VL through 120 volt operation. With that, we are able to control the load time, the dump time, purge if you have it, or proportioning, one or the other, blowback, the number of pulses, how long the pulse is, and when it should pulse, whether that's every cycle or every other cycle, and gives you the flexibility to make this loader operate the way you need. With the XSL and the GSL, they have the same controls between the two. Now, these loaders may be up high in another location. They may be up on an extruder, an injection molder, it could be up on a blender, and you don't have easy access to these units, where you only want to be able to go up there when you're doing regular maintenance. So you're going to want to have the controls readily accessible. Well, in each self-contained loader situation, the controls are remote mounted. They're not mounted on the body unless you're looking at the XSL and the GSL, which you can actually pull this pendant off. We have excess cable for allow it to be brought down to operator level. Where with the VL, the power cable that plugs in to the unit up here, that cable is an extension, allowing 8 feet from the unit with options of longer cables. With the XSL and the GSL, we can actually extend this cable even longer depending on your application need, but we provide adequate amount for most applications. We went through the differences between the VL, the XSL, and the GSL, but there is an honorable mention that I would like to bring to your attention. These three loaders behind us are primarily used for pellets and fine clean cut regrind. We do have an offering that allows us to work with dustier regrinds and pulverized, granular, or powder-like material. And this will be a variant of our VL. With the VL, we have that filter disc that allows us to work with standard pellets and regrind. Well, that will be replaced. We actually have a whole body section that will be attached to this unit that utilizes cartridge filters that are rated down to 1 micron. It's a polyester with a Teflon coating, so it's washable and reusable. And what that will do is it'll actually provide finer filtration for the motor, protecting it from more minute particles that will be found in those niche applications. Now that we've discussed the differences between the three motorized self-contained loaders that Novatec offers, you can get more information on these if you visit our website at www.novatec.com or reach out to one of our sales representatives for information and a quote. Thank you for watching.